Good afternoon, everybody. Thank you for joining us this afternoon here at Qubits Learning, where we will go and discover AI beyond prompt engineering, where we're going to discover AI. Now, I just want to give you a little brief about Qubits, okay, and who we are. Qubits Learning is a global leader in K-12 computer science and artificial intelligence education, delivering an integrated ecosystem of standards-aligned curriculum, professional development, and digital learning tools that enable schools and districts to build scalable, future-ready computer science programs across all grade levels. I would just like to mention also that last year, Qubits and Cengage Schools became partners, okay? So this is also, I just wanted to mention, in 2025, Qubits entered into an exclusive global distribution partnership with Cengage School, a division of Cengage Group, extending its reach across international markets through an established worldwide distribution network. I would like to introduce one of our presenters. Our key presenter today is Dr. Whitney Duff, who has 20 years in education. She comes as a former classroom teacher and instructional coach, curriculum developer, and PhD author. And she has background in STEM curriculum and instruction. And our other presenter, I'm delighted to introduce, is Mr. DePaul, who is the co-founder of here at Qubits Learning, has 20 years plus in global education, pioneer in hands-on STEM learning modules, specialist in K-12 computer science and AI curriculum. Thank you so much for them. Thank you. Now, we have obviously some norms that we would like to go through with the sessions that we're going to have this afternoon. We would like you to stay fully engaged, be open to new ideas, and engage with chat or polls when prompted, please. And reflect honestly on your own teaching, because we want to learn from you as much as you want to learn from us. So that would be very good. Thank you.
All right. Thank you so much, Samantha, for your introduction. Just double checking to make sure everybody can hear me okay. Samantha, if you'll give me a thumbs up, or DePaul, just so I make sure everything's coming through loud and clear.
Yeah,
all right,
everything's
great.
fine.
Thank you. I am excited to be here with everyone. Today, we're going to take a bit of a journey together. We'll start by grounding our conversation in the AI that you already experience in the real world. And the thing is, AI is more pervasive than most people are realizing. From there, we'll look at some live demonstrations of AI in action, and we'll use those to open up the hood of what AI actually looks like, how it learns, how it fails, and what that means. Then we'll shift into the part that I think will resonate most with everyone in this room: why this is genuinely hard to teach, what we hear from teachers every day, and how the Qubits Discover AI curriculum was designed to address those challenges head on. We'll do a live demo of the curriculum and the AI IDE, and we'll close with time for your questions about the curriculum, about implementation, or about AI education more broadly. Let's get started. Before we dive in, I have a quick question for you. Go ahead and think about this question. When did you first use AI, either personally or in your work? We'll give you 15 or 20 seconds of think time here, but then I'd like you to just type your answer directly into the chat. I see 2 years ago, 3 years ago, most recently used. Yeah, maybe 2 years, 2025. Perfect. Long time. Awesome. I see that most of us are landing in a range past 2022. And you know what? That makes sense. I see that my video came off, so let me turn it right back on. That makes sense because November 2022 is when ChatGPT launched, and the conversation around AI became impossible to ignore. This is the moment when everything shifted. But here's the thing, and this is where I want us to start today. You have almost certainly been using AI for much longer than you realize. If you've ever had your phone finish a sentence for you, that's predictive text, machine learning. That showed up on iPhones around 2007. If you've ever had a streaming service like Netflix recommend something you wanted to watch, that engine has been running since around 2006. If Siri or Google Maps has ever rerouted you around traffic in real time, that's also AI, and it's been in your pocket since around 2011 or 2012. If you wondered why a certain email went straight to your spam box instead of your inbox, that's a machine learning model making a call on your behalf. Those spam filters have been doing that since the early 2000s. The difference is none of those things asked you for a prompt. They just quietly did their job, and we didn't call it AI. Which brings me something I want to show you right here in this call. For one more example of how AI operates quietly all around us without ever asking for a prompt, I want you to look at this Zoom call, the one we're in right now, exactly as it is. Take a moment. Look at your screen, look at the other participants, and at all of the features that are available to you in this tool. And drop into the chat. What AI do you see? I'll give you a little think time, and then we'll watch for some responses in that chat. Okay, we're seeing the facial recognition, noise cancellation, captions, AI summaries, transcript, computer vision, Google Assistant, virtual backgrounds. Great. There are some really good ones in here. I see that you thought of transcription, note taking, noise cancellation, blurring, and replacing the background. But the one I want to focus on is this one right here. Several of us are sitting in front of a blurred or replaced background. It looks mostly seamless, and it's happening in real time. At no point did anyone type a prompt to make that happen. And behind it is a type of AI called computer vision. And that's exactly where I want to start. So what is computer vision? I see you speaking of vision. My camera has come off again, that dang thing. So what is computer vision, and what is it actually doing right now? Computer vision is a branch of AI that teaches machines to interpret and understand images and video the way humans use their eyes. Instead of processing language, it processes pixels. In the case of our Zoom backgrounds, our computers are looking at our video streams feed frame by frame. For every single frame, it's asking which of these pixels are person and which of these pixels are background. It's making that call thousands of times per second and replacing or blurring everything that isn't us in real time. No prompt, no language model, no ChatGPT, just a model that was trained to see. And this is the idea we're going to be anchoring our whole conversation in today. AI is much bigger than the conversation suggests. When we talk about AI in schools right now, we're mostly talking about one branch of it, generative AI. large language models, and prompt engineering. And all of that matters, but it's one slice of a very, very large field. Computer vision, predictive models, recommendation systems, speech recognition, these are also all AI. And they're the AI your students are already living inside every single day. When we look at the market, both the tools being built and the curriculum resources being written, the conversation is dominated by generative AI, ChatGPT, Claude, and Gemini, prompt engineering, and how to get better outputs from these tools. And we are not here to argue against any of that because it does matter. We agree that students should learn to work with these tools. But here's the thing. Remember, it's a very small slice of a much larger picture. So what does AI actually include? The Zoom background we just talked about was computer vision. Netflix recommending your next show, predictive models. Your phone unlocking when it sees your face, facial recognition. Siri understanding your voice, speech recognition. Self-driving cars, those are autonomous systems. These are the AI your students are already encountering every single day. And right now, when we as educators are focusing too exclusively on large language models, we might accidentally be producing students who know how to use AI, but not how to understand it, evaluate it, or build the systems that are shaping our world. This is the gap we are here to close. To make this really concrete, I'm going to be handing it over to DePaul, who is going to take you inside one of these systems. What you're about to see is a live demo that he will use to build the same kind of model that powers the Zoom background we are sitting in front of right now. Let's take a look. Over to you, DePaul.
Thanks, Whitney. Sorry. All right. So let's try to build the Zoom background from scratch. Now, any AI system, like any computing system, starts with an input. So like Zoom, we're going to pull in our camera input, which is going to pull my camera, and you can see my background over here because there is no virtual background like Zoom. Now, what do we need? For the AI to put a virtual background on my back, it has to differentiate my body from the background. Now, we call that body segmentation in the computer vision field. So we need a model, an AI system that does the body segmentations, which I'm going to drag and drop over here. Now, this is a pre-trained model. That means it has been trained with millions of different examples of people wearing different clothes, different backgrounds, different, body sizes, and it has learned those patterns to identify a human body from its background. Now let's connect the input to the body segmentation model. Now we would like to see what the output of this model. Now this is going to mask the body shape, so I'm going to pull in a mask visualizer and I will connect the output of the body segmentation model to the mask visualizer. Here you go, and the camera input as well. There I am, right? You can see now the AI has segmented my body from the background. It can identify even my hand as a part of my body. Isn't it AI? Isn't it smart? Now, what do we do next? We need a virtual background. Now, right now I have a white background, but I do like my Zoom background. So I need to input the background image. I'll pull in an image input. Let me get the Zoom background as the input. And I need to mix the output of the body segmentation with the image input. So I'm going to use an image mixer. As the name suggests, it is going to mix my camera input and the segmented body. So let's do that here, and the more desegmented output over here. There you go. Here I am with the virtual background, exactly like Zoom. Yeah, Zoom might be doing a little better job because they have much faster servers. This is running on my local computer. So, but still, yeah, here is my virtual background. You can see my hand. Yeah, here you go, right? Something that we built right in this call in few minutes. Great. Over to you, Whitney. You can
All right.
continue.
Thank you so much. Hang on 1 second. Let me find the button. Okay. So you just saw that DePaul was able to build that model from scratch, and it looked almost exactly like the one that Zoom is doing for us. Now, no pun intended, let's zoom out and ask, where else does this technology show up? I'll give you a personal example. I just traveled out of the country a few weeks ago, and when I arrived back home and went through the TSA checkpoint, they scanned my face, matched it to my passport, and confirmed in seconds that I was who I said I was. Same technology and very different applications. Here are a few more examples. In medical imaging, AI is scanning X-rays, MRIs, looking for abnormalities, changes from a previous scan, and often with a higher degree of accuracy than the human eye. This is incredibly promising. What about retail transactions? Some stores are using systems powered by computer vision, sensor fusion, and deep learning to eliminate cashiers and the checkout process. You just scan your card, the AI builds a virtual cart as you shop, and then your card is charged when you leave. Autonomous vehicles. Self-driving cars are equipped with all kinds of sensors to detect their surroundings and are running programs designed to make them safe, or at least we hope. Even with all of this around us, we almost never stop to think about how it works. We just appreciate that it does. But here's the thing about all of that. It doesn't always work perfectly. Let's look together at a few recent headlines. Look at the examples on the screen. First, on the left, a man was able to purchase a 2024 Chevy Tahoe for $1. These vehicles are worth quite a bit more than that. A quick Google search said they may routinely go for about 60,000 US dollars. So an AI chatbot made a commitment it had no authority to make, and it did it with full confidence. In the middle, a Waymo robotaxi drove the wrong way down a busy street in Austin, Texas in December 2025 into oncoming traffic. It was fully autonomous. There was no human at the wheel. Then again, in April 2026, a Waymo had done the same thing in a school zone with children present. In both cases, there was no warning light, no alert, no hesitation. The system did not know it was wrong. On the right, in April 2026, a Claude-powered AI coding agent deleted an entire startup's production database and all of its backups in 9 seconds. The company was called Pocket OS. The agent had been given explicit rules, including never run destructive or irreversible actions, but it ignored them, making an autonomous decision to fix a credential issue by wiping the database entirely. When the founder asked what happened, the AI confessed, "I guessed instead of verifying. I violated every principle I was given." The data was eventually recovered, but again, no warning, just a confident, autonomous action with catastrophic consequences. Now, think about those higher stakes applications we just talked about, like facial recognition at our borders or diagnostic imaging. These systems are making consequential decisions at scale. Getting it wrong isn't just an inconvenience, it can be catastrophic and often happens quietly. The examples that we looked at are not anomalies. There is a pattern there. And they're the reason that we make the case for AI literacy the way we do, not as a nice to have, and not out of this job displacement anxiety that we hear a lot about. This whole AI is coming for our jobs framing tends to flatten what's actually at stake. The World Economic Forum's Future of Jobs report from 2025 found that AI and big data are now the fastest growing skill category globally. 86% of businesses expect AI to transform their operations by 2030, and the students inside your classrooms right now will spend their entire careers inside that transformation. But here's the thing. The urgent case for teaching AI isn't just about employability. It's about the fact that these systems make mistakes quietly, confidently, and at scale. And only the people who understand the underlying concepts will be equipped to catch those failures, to build better systems, and to ask the right questions before they trust the output. That's what the 4 pillars on this slide are all really about. Career relevance. Every field is becoming AI augmented: medicine, law, finance, journalism, design. Understanding these systems will matter regardless of what your students end up choosing for a career. Critical thinking. Detecting bias and errors in AI requires knowing where they enter the pipeline. You cannot audit what you cannot see. Responsible use. Students who understand how models are trained and what they can and cannot do are the ones who will use AI ethically. And lastly, agency. There's a difference between consuming these systems and shaping them. We want our students on the right side of that line. Let's pause here for a quick poll. So it should pop up on your screen. And we're asking here, what is the hardest AI concept to make real for students? So let's take about 20 or 30 seconds here, have everybody select from the list, and then we'll take a look at those results. All right. So a pretty good mix. We see mostly an even spread across those, but we do see also that we're falling into the all of the above category. And, truly, this tracks with what we hear from teachers all of the time. And it connects with what we just saw: the Waymo, the Pocket OS agent, the chatbot that sold a truck for $1. What those moments have in common is that the AI had no idea it was wrong, and the people relying on it didn't have the framework to catch it either. That gap is what we're trying to close. So here's our honest challenge. The concepts behind that gap, like bias, training data, model evaluation, they are legitimately hard to teach. They can feel very abstract, super technical, and hard to make stick with an 8, 10, or 14-year-old. So DePaul is going to show you something. This demo isn't about impressing you with what our IDE can do, but certainly it will do that too. It's about showing you what it feels like to teach one of these hard concepts from the front of the classroom with a simple tool in a way that students can actually get. By the end of this, you'll have seen bias enter a model in real time, and your students can too. All right, Mr. DePaul.
Yeah. All right. Yeah. When we think about teaching AI to students, whether it is primary or middle school or high school students, we think that, it's too complex for students to learn. Now, we will try here to teach some of the key concepts in AI and machine learning to, students even from the primary school. In this simulation, what we are trying to do is to learn about what a model is, what a machine learning model is, and how data plays a critical role in the quality of the model, the idea of a data set and the process of training a model. And the biggest principle in AI, garbage in, garbage out. If you train with garbage data, you get garbage output. So let's see how we can, teach these concepts to students. Now let's start with an untrained model. Now, what does a model mean? A model is a special algorithm that can learn from examples. And now we have an untrained model. We have an algorithm here, but it hasn't been trained yet. So let's try here. And our task is very simple. It is to classify circles and squares. Now we have, of course, different types of circles here, bigger, smaller, some of them side is clipped off, similarly squares, which are, placed in different areas, different sizes. So let's try with an untrained model. Yeah, it got the first one right, got the second one wrong. Yeah, it's guessing squares as circles, sometimes circles as squares. It's all over the place, right? You can see here, it's making a random guess. So an untrained model is practically useless for us. It is just as good as, a random guess. And you can see it's even worse than a random guess, 11% accuracy. Now we get this core idea into the students that, AI is not born intelligent. We have to train and make it intelligent. Then let's go into the second step to train the model. So for training this model, first we need the data. So not just any data, organized data that are classified and labeled. That's what we call as data sets. So we introduce the idea of data sets. Oh, here is a number of circles, number of squares. Do not hear that, we all have red circles, although we have different size circles, bigger, smaller. We all have blue squares, bigger and smaller. Now, let's drag the circles to the circle label so that we can tell AI, okay, hey, this is an example of circle and these are examples of squares. I can make it faster by selecting multiple and dragging together. Here we go the squares. I got 10 squares. Let me get a few more squares. And let me get some circles too. All right, and this process actually mimics how we actually learn to recognize a square or a circle. Somebody during your school days, maybe a teacher or parents must have shown you squares and circles and told you, hey, these are the squares, these are the circles, right? Same process we are doing with AI. We have a data set, we have labeled those circles and squares from the data set, and then click training. So right now, it is actually training a real machine learning model, neural network model, to train and learn this pattern. And it says accuracy 100%. This doesn't mean anything because this accuracy is based on the examples that it is trained with, right? So we can only evaluate quality of a model when we are testing with new scenarios. Okay, so we go to test model. And again, you see here, oh, you have red circles and squares, but these squares and circles are slightly different from the ones that we use for training. Let's see how this works. Circle, yes, 100% confident. Another circle, yeah, it's doing pretty good. It trained well on the data that you gave. A square, it is predicting the square, and very, very high confidence level. So here we introduce the students, it's a probabilistic model. There is a probability and probability can be as close as 100. And here it is able to predict most of the shapes, accurately, squares and circles. We can continue to try with different circles and yeah, it's doing a pretty good job. Do you think I would like to stop here for a moment and if you can use your chat and tell me here that do you think this is a good model for classifying squares and circles or not? And why do you think so? All right. So yeah, it is able to do a very good job of classifying red circles and blue squares. Let's try a different test database. Here I have, red and blue circles and red and blue squares. Let's try again. Yeah, circle, red circle, it does a good job. Let me try with the blue circles. Oh, It predicted it as a square with absolute confidence, 100% confidence that it's a square. Yeah, I'm trying again, a blue circle. Oh, again, predicting as a square. Let me try a blue square. Yeah, it is accurately predicting. Let me try a red square. Now it is predicting a red square as a circle. Let me try a few more shapes. Do you see what is happening over here? Instead of the shape, looks like it is actually classifying by color. And why do you think that happened? Our objective was to train the model to classify shapes, right? And we gave red circles and blue squares. And unknowingly, what we did is what we call a bias. Now, we cannot tell AI what to look for. All that we can do is to give examples, and AI picks its own patterns. Now, AI always picks up the easiest pattern. In the dataset that we trained with, we had all red circles and all blue squares. So instead of looking at the shape and learning the shape, what AI did, it picked up the color. So it thought, all red things are circles, all blue things are squares. That's what it is doing over here. All the red shapes, irrespective of circle or square, it is categorizing as circle, and all squares and all blue shapes, irrespective of the shape, as a square. So this is what we call a bias in an AI system, and that comes unintentionally. This is the same bias that causes the AI that filters, job applications and give more preference for men than women. It's the same bias in the system, computer vision, that often predicts a black person as a criminal with much more probability than a white person. So all of these biases comes into the system not because AI is bad, it is because the data that we are using is not diverse enough. Now, how do we fix it? Having better data. Let's try the data set 2, where we have both circles and both color circles and squares. I'm going to pull the circles together here, maybe a few more. And this is something kids can play around and figure out that, more shapes you have, more training data you have, better the training results are. Here we go. Okay, maybe few more squares. Now I am giving squares and circles of both the colors so that instead of AI generalizing on color, it can focus on the shape, right? So because it cannot say that, okay, here it is circle or blue squares, because in both labels you have, both the colors. Let's train now. It's training the same model that we used before. Yeah, again, 100% accurate. Let's try here. Okay, blue square. Yeah, it's predicting as a square. Now a red square. Yeah, that is also predicting a square. So looks like we solved the bias problem here. All the squares are classifying like a square. Let me try a blue circle, a red circle. All good, right? It's doing a pretty good job. 99% probability that it is a circle. Now, do you think this is bias free? Think again, right? I mean, is all circles and squares of these color? It can be of multiple colors. Let's look at another test data set where we have, circles and squares of different orientations, different background colors, etc. Let's see how it recognizes this square. Oh, it's full confident that it is a circle, And let's look at a circle. Yes, it is doing a good job. Let's try this. Yeah. So although we solve the red and blue circle problems, still we know that the real world data is messy, it's too diverse, and you need a lot more training. Of course, you can go back to training and use a third data set which has more diverse data and get a better model. The whole idea here is that students understand the role of data and quality of data, how it impacts the AI training, And when you have a lot of diverse data, and of course, you can continue to play around with this. And we have a large data set of 335 images down here of circles and squares. More the data they use, they get better output. And another key concept is, of course, the idea of, the garbage in and garbage out. What if I tell a wrong data to the AI? Let's say I am going to tell, okay, these are circles. I am labeling circles as squares and squares as circle, as you can see over here. Let me put a couple of more. Then train it. And all right, let's test it now. Now, of course, we gave garbage, right? We told, circles are squares and vice versa. It's incorrect. And what does the AI do? It does the same thing, right? We told, circles are squares, so it predicts circle as a square and square as a circle. Now, if you look at this sort of a virtual simulation with a real AI model in it, we are able to teach students relatively abstract and complex concepts that really drives AI and machine learning, using this simple example. All right, Whitney, over to you. You can continue.
Okay, thanks again. Love watching that. So you just watched Paul fix a model by fixing the data, not by writing a better prompt, by understanding what was happening inside the system and by changing it. And this is the distinction that we really want to draw today. Again, the conversation in education right now is very heavily focused on prompt engineering. It's not wrong. It's a real and useful skill. But here's the analogy that we are making. Prompt engineering is like driving the car. What we just saw in that demo is knowing how the engine works. And there's a third thing we need students to know. We need them to know when not to trust the car at all. Think about the applications that carry the highest stakes, like those systems that were scanning our diagnostic images, or the ones deciding who gets flagged at a border crossing, the ones reviewing job applications before a human ever sets eyes on them. These are not large language models. They are complex, data-driven systems with real consequences when they get it wrong. And they will get it wrong. We've just seen that. If all we teach is prompt engineering, we are producing fluent users of one slice of AI, while the larger, higher stakes systems run invisibly in the background, and our students have no tools to question them. We want our students to be able to drive the car, but we also want our students to be able to look under the hood, hear if something is off, and say, I don't think we should get in that car today. Now, we've just made the case for what AI education should look like. And if your reaction right now is somewhere between yes, absolutely, and okay, but how, that's exactly the right place to be. Because teaching this well is genuinely hard. And we want to be honest about that. But before we show you what we built, we want to ask you directly, what's your biggest struggle when it comes to teaching AI to students? Take a moment. There's no wrong answers here. And honestly, if you could select all 7, we would understand. We'll take a few seconds and watch the results come in. All right, what do we have? No clear curriculum or roadmap. Looks like it's coming in with the highest percentage. I also see here AI concepts feeling too complex for my students. AI changes too fast to keep up. I can't show my students what's inside the model. Yeah, so let's hold on to this, because what you've just told us right now in this room is almost word for word what teachers have been telling us for the past 2 years. Let me show you. Look at this slide and then think about those results. The answers that you picked in that poll, we've been quietly collecting versions of those same answers from teachers we work with for the last few years. What's on this slide is not a curated highlight reel, it's a pattern. The same struggles, the same language, the same frustrations from teachers across every grade band, every school type, and every level of technical confidence. Let's go. First of all, I don't know where to begin. AI feels like a moving target. By the time I've built one lesson, the tools have already changed. Where do you even start? My students think they already get it. They are using ChatGPT every day, mostly better than I am. Convincing them there's more to learn is half the challenge. I'm not confident enough to teach this. I did not learn AI in school, so I don't have a computer science background, and this gets complicated fast. It's not an excuse, it's just the truth. The tools are either too simple or too hard. Block coding feels too basic, Python is inaccessible, and there's almost nothing in between that's actually built for my classroom. There's no clear roadmap. There's YouTube videos, blog posts, and it can all be stitched together, but there's no sense of what to teach when or what's appropriate for each grade. I can't show students what's inside the model. AI is a black box, and that's precisely why it's so hard to teach critically. It's hard to explain what you can't see. Every one of these became a design requirement, not a nice to have, but a requirement. Let us show you what we built. So we took every one of these concerns and we asked, what would a curriculum that actually addresses this look like? This slide here maps each challenge to what we built in response. And the through line is this. We didn't build a curriculum that ignores what teachers are telling us. We built one in direct response to it. Discover AI is organized around 6 domains of knowledge that form the structure of our curriculum. These are not arbitrary. They're mapped to the global AI frameworks being used to guide how students should learn about and use AI, including foundations of data, data that fuels AI, algorithms that guide AI, building AI applications using AI, and responsible AI. Whatever frameworks your school is using, you'll find alignment here. The domains are delivered through a curriculum built around 4 design principles. It's project-based and practical, so that students are building real AI projects from the start. You saw 2 examples of this today, a model that does what Zoom does, and one that demonstrates how bias enters the pipeline. Learning happens by doing, not by memorizing definitions. We opened up the black box. We don't stop at how to use AI. We open it up so that students can see the data going in, watch the model train, and observe what happens inside. The algorithms and sequences driving these applications are the same that they interact with daily. There's real data and real models inside this program. This makes for very authentic learning. We use the same kinds of data sets and algorithms you'll find in the industry, not simplified simulations of them. And as much as possible, it mirrors what AI engineers are doing in the field. It's visual without complexity. Students build real AI pipelines in a low-code, drag-and-drop IDE, real concepts without a syntax barrier. And what makes this a curriculum rather than a collection of lessons is a very intentional spiral. Those 6 domains of learning are revisited at every grade band. The content doesn't reinvent itself, it deepens. You now understand why going beyond prompt engineering matters. The world is running AI across every industry and sector. These are high stakes, high consequences systems, and students need to understand those systems. We've built the tool that makes that teachable. Here it is. You've seen glimpses of it today, once when DePaul built the background segmentation model, and again during the bias demo. But those are just 2 tools inside of our much larger platform and curriculum. Welcome to Discover AI, our AI IDE, brand new. And it was built from the ground up with one audience in mind. Teachers who want to take their students inside AI without the complexity of sophisticated programs. The AI IDE has 2 primary modes. The train mode which lets students use prepared data sets to train models, evaluate them, and watch them succeed or fail in real time. While the build mode lets students assemble model architecture block by block, seeing what a layer is, why depth matters, and how design choices change behavior. It's browser-based, Chromebook-friendly, no installs required, and now DePaul is going to walk you through it.
Thank you, Whitney. All right, just coming back to the AI IDE, the last two demos that you saw was all part of that AI IDE and its capacity. Now, this why we built it AI IDE is to abstract the complexity of building, textual AI programs, which is a real limitation in K-12 AI education, and make that accessible for all learners through a very simple drag and drop mechanisms while building real AI models. So we have all the broad elements that is part of any AI model, like the input. There's a variety of inputs such as textual inputs, voice input, or a camera, image, all the ways we interact with an AI. We have various processors like text to speech, translation, image editing, and so on. We have all different kinds of computer vision models, text-based natural language processing models. And this is something which is under constant development. We have more of generative AI models also releasing in the coming weeks. We also have a custom classifier that students can do train in the training mode and bring it to the build mode. We also have different output viewing options over here for different purposes. Now, we have already seen how we can segment the body and do a virtual background. Also, we have different models, such as let's say, for example, object detection, a model that is specifically pre-trained for identifying objects and classifying them with the probability. And all of these AI pipelines works as simple as connecting blocks by simple lines, by clicking them together. And I'm just going to build a simple object detection model as an example here. There you go. And there we go. Now, you can see over here, it is detecting me as a person. Of course, the image on the wall, sometimes it's predicting as TV. It does look like a TV. And it can detect, let's say, my cell phone and stuff like that. So primarily, this IDE is a simple drag and drop, and students can choose what they want to achieve. They can choose an appropriate model. They can connect these blocks together and literally build any AI application. Now, after they do it, they can further program these to do certain actions. Like, for example, if they, if you see a person, a human, raise an alarm, maybe a burglar alarm, etc. So it allows you to do further action ahead of this. Although it is beyond the scope of this webinar, we will have future sessions. We will take you through more of those examples. Let me quickly bring in another example, which we are going to use it as a part of the project, which is to identify the face landmarks. So, one of the very common AI applications where you virtual try on glasses or, makeups, etc. So this face landmarks is one of those models that help you achieve that. So what the face landmarks does is it identifies different points in your face. As you can see, 68 unique points, all over, right from your forehead to your cheeks, your eyebrows, nose, lips. You can see, right, like how it identifies. Although I am wearing glasses, it can know where my eyes are exactly. I can remove it, tilt my head. It does a pretty accurate a representation of my face and identifying the key landmarks. This is the technology that is used in face unlock, wherever you go through an immigration where they do the face identification. This is largely built on this model. So similarly, we have gesture classification, pose identification, and all these different models available that they can build applications with. Now let's go back to our virtual background example that we built. Sort of a quick reminder, we had the camera input. From the camera input, we wanted a model that segments the body out of the background, which I did with the body segmentation model. And here is the output of that. Then I wanted a virtual background, so I mixed that up with a background image in a mixer. Now let's do a little bit more. I want to try out a virtual glass, um, still with this virtual background, right? So of course I need the virtual glass. First, I'm going to bring in my virtual glass image. Here it is. Here is a beautiful sunglass that I would like to try. And now I also need to place it, near my eyes. That requires a face landmark identification that we just used a while ago. I'm gonna hide this preview and this one as well. So the face landmarks gets the camera input. So I connected the camera input to the face landmarks. You can use the same inputs for multiple processing blocks. So the same camera input, we are doing the body segmentation, and another model is identifying my face landmarks. And then I want to put an augmented reality sticker. In this case, it is a virtual glass. So the sticker is the image input that I connect together. The face landmarks goes from the landmarks model, and the image from the image mixer. So I connect these together, and all right, there you go. Here it is, right? You can see my virtual glass try on over here. I can move my head, turn, and you can see, this being here. Of course, it is running, the processing is running on my local computer, so you'll see a little bit of delay in processing, but yeah, it is able to identify where my eyes are. It is able to segment my body. It is able to apply a virtual background, all of these things together. And we are making such project possible for school students to do by allowing them to use these pre-trained models, by just connecting them together using blocks and creating their applications, as easy as this. Now, you may ask, okay, all right, these are all pre-trained models. How do you teach them how to train? So that is where we have the train mode. And in the train mode, you can create different classes and provide training data. We also provide data sets up for various projects, already prepared data sets that makes that whole process of creating AI models much easier and practical for the classroom, because often collecting data takes time. So we do provide some pre-created data sets as well, and they can, of course, let's say, create their own training data as well using camera. And these training support not only image, we also support text-based, classifying emails as spam or not, classifying feedback as neutral, positive or negative, etc. So right now I'm just going to do a very simple example. I'm going to identify my hand, or is it a fist, or say no hand. So I open my webcam. Since it's a computer vision model, let me start with my hand. Just click on capture. It captures the image of my hand. All right. Done. Then my fist. About 28, maybe a few more. There you go. And when there is no hand, that's me without my hands. So a few examples of that. Right. So easy. I trained that model. And for advanced students, we have more settings where they can see how many epochs, how many rounds of learning, the batch size, learning rate, etc. They can, of course, play around with and learn that as well. And once they're trained, they can start predicting, right? Like, yeah, there is no hand, and it is predicting with pretty good confidence. Let me try my hand. Yes, there my hand is. Or there my fist is, right? So pretty easy. Now, what this IDE allows is not only to, train that model, they can click on export model and they can bring that model right into the build mode by simply, dragging that custom classifier and uploading the models files that we just exported. All right, so we have exported. So it has identified the three classes, the hand, fist, and uh, no hand. And of course, it needs the image input, the camera input. And of course, you need to see the output. So I'll pull in the classification, how it is classifying, because it's a classification model. Oh, here you can see there is no hand. And I show my hand. Yeah, it identifies my hand, identifies my fist. Hopefully you can see over here, right? So here is my hand, my fist, and no hand. So yeah, so you can bring your trained models from the train mode into the build mode. And although we focused more on the computer vision models in this demonstration, we also support text-based model, natural language processing, voice-to-text processing, and all other forms of AI as well. Now, what this gives students is an opportunity to apply AI into different applications without going through the complexity of creating very complex programs, which are often beyond the level of a K-12 student or even an engineering student. So it gives like immense opportunity. You can also compare, the model that you trained with a pre-trained model as well. So here is a gesture classifier, which is pre-trained hand gesture classifier. So it gives opportunity for students to take up multiple models, train their own models, compare with the pre-existing model, etc. Let's do a quick check of that. So I'll bring in another classifier where I'll use the output from the hand gesture classification here. The first one you see over here is the one which I just trained. The second one you see over here is from the pre-trained one. So let's try. Okay, here is my fist. Yeah, my model predicts it as the fist. This says thumbs up. Yeah, very close. Um, Oh, here it says hand, it says four fingers. Yes, it's identifying, but my model is more confident because it is only trained on my hand. So if someone else shows the hand, my model might not perform that well, but the classifier, might work better. Right now, both of them has like pretty sure that there are no hand out there. So this is the AI IDE, and we are going to bring in a lot more features as you go forward with this. So this is like one place where we can have real practical AI projects, including prompt engineering. We will have these generative AI block models as well coming here. So pretty much all aspects and domains of AI can be covered with practical projects using this IDE. All right. Thank you, Whitney. We can continue from here.
Awesome. That is pretty incredible, isn't it? Definitely makes me want to go back into the classroom so I can have that fun thing to play around with. I did see a couple of questions come through while we were watching the demo. We'll get to those when we get to our Q&A section. We want to make sure we answer all of your questions. So the IDE that you just saw, which I hope knocks your socks off the way it does mine, is most definitely the centerpiece of our Discover AI curriculum, but it's just one piece. Discover AI is the most complete AI solution that's out there. Everything on this slide is included. So it comes with built-in lesson plans that are full, ready-to-use lesson plans with objectives, facilitation notes, timing, differentiation suggestions, so that the teachers who are guiding their students in this AI exploration do not have to be AI experts themselves. The lesson plan is intended to teach them alongside their students. There are assessments, again, built directly into the curriculum so that teachers always have a clear picture of where their students are without having to build your own quizzes and assessments from scratch. Slide decks are included in every lesson. So these are designed for classroom facilitation, a really nice anchor for you as you're going through the lesson. You can use them as is, or they're also downloadable as Google Slides if you'd like to adapt them. Either way, it's one less thing that you have to worry about. There are videos throughout. These are short curriculum-aligned videos that introduce and reinforce concepts. They're useful for students who want to go back and visit something at their own pace, or for teachers who want to flip part of the lesson. We've just talked about that AI IDE. It's a drag and drop sandbox that you've just seen in action. Again, browser-based, Chromebook friendly, no installs, just ready to play and make those complex and hard to teach AI concepts visual and better easy to understand. We've also got AI simulations in the curriculum. These are hands-on simulations that powered both demos. They're object detection models, bias classifiers. Students don't have to watch AI to be able to train it. They do it, see it fail, and fix it. This is why we describe Discover AI as the most complete AI curriculum solution available. Not because it has the most features, but because it has everything teachers and students actually need in one place working together. So let's come to one more poll here. Now that you've seen it, we want to know what resonates most for you in your context. Which of these actually matters for your classroom, your school, and your students? Again, we'll pause and wait for the results to come in. All right, a lot of you are drawn to the drag and drop IDE. Again, no code, real AI. We also see some interest in the train mode and the curriculum spiraling, the pacing guides. Those of you who answered something else, feel free to drop it in the chat for us so we have a better sense of which features are most important to you and what might be something we need to focus on as we continue discussions with you about what a pilot might look like for your school. Thank you. Before we close, I want to come back to the central idea that we planted earlier in our time together. When we got going today, I said prompt engineering is driving the car, and that's a real skill. We're not dismissing it. But what you've seen in the last hour is what it looks like to go a step further. You saw how students can build a model behind the Zoom background from scratch. You saw a model fail because of bad data, and then you watched it succeed when the data got better. You saw a curriculum that opens the black box instead of teaching around it. And that's what we mean by knowing how the engine works and when not to trust it. Students who leave your classrooms with that understanding are not just better at AI. They're better at asking hard questions about the systems running their world. And I think that's what we're all actually trying to do. Let me close with why the stakes are high enough to matter. Students entering school today will spend their entire careers working alongside AI. That is not a projection or wishful thinking. It's very much already our reality. And the question isn't whether they'll encounter these systems. It's whether they'll understand them well enough to use them wisely, question them honestly, and build them responsibly. That's what Discover AI is for. If what you've seen today resonates, would love to talk about what a pilot looks like for your school. Our team is here, so reach out, ask questions, and let's figure out together how to make this real in your context.
Thank you, Dr. Whitney. That was absolutely fantastic. The session's been amazing this afternoon, and I'm sure all the teachers will agree with me. It was really, really enlightening. We have got some questions. Just one question now for Mr. DePaul. Can we export the model as a link and host it? Can we copy this to a website, for example? There is a website designing through Google Sites. Can I copy the code of this classification?
Right. So one of the things with this classification models are often students use their faces, and for training, and as you have seen, right? I mean, my picture was always there. So we want to make sure that they are able to use it only within the platform. Don't take it outside. So currently, yes, we do not provide a link to take it outside, and that reason is mainly privacy reasons. However, within the AI IDE, we are creating systems where they can use those models to build websites. As if somebody who might have used Qubits platform in the past will know that we have built in web editors and other IDEs available. These models that they train in the AI IDE will be able to use in those other IDEs that Qubits platform support. So we do not allow these models to be as a link to be exported out of this platform, mainly for the privacy reasons and the restrictions of student privacy to enforce that.
Okay, fantastic. Now, is there any other questions that you would like to ask? If you would like to put them in the chat box for us. Okay, this is another question for you, Mr. DePaul. Do you have an AI application dedicated to electronic circuits, or can it be integrated to the electrical or electronic circuits?
All right, so we do have, as a part of our offering, we do have a hardware called BitQ that we offer along with our courses, and BitQ supports tiny ML. It's a machine learning package for micro devices. So yeah, we have an IDE for integrating machine learning models into our BitQ hardware. We do not support external electronic hardware, but our own BitQ processor, we support machine learning models.
Okay, fantastic. Dr. Whitney, this is a question for you. What's the most common misconception schools have when they first try to introduce AI education?
I think the most common misconception relates to the key idea that we've been trying to share here today, which is the overemphasis on the use of AI tools. We see a lot of schools purchasing subscriptions to AI tools that are intended to make students' lives easier or teachers' lives easier. And so there's an investment in the productivity that is often afforded by AI, or the efficiency or the accuracy, right? And so we sort of think that teaching AI means just bringing in a lot of tools into the universe of tools that most schools have at their disposal, which is great when that happens. But in our opinion, it is missing the key idea here, which is we really want students to be able to understand these systems, and they will not get there simply from using them. An example that springs to mind is the use of ChatGPT for if a student is being asked to write a research paper, for example. They might ask ChatGPT to give them 15 or 20 articles that have been written on a subject. It might very well make those up. It might very well invent articles that have been written on a subject, because that's what generative AI does. It generates information, right? So half of the battle is teaching them the prompt engineering to make sure that it doesn't do that. But really, we want students to be able to do that work of understanding what's happening, understand it, so that they can better evaluate its output. So again, sort of relates to this idea that we've been sharing consistently throughout, which is it's not enough just to give them the tools and to make their lives easier with those tools. We've got to do something deeper and really teach them the concepts and the systems and the structures that are underneath so they can be better stewards of it.
Okay, thank you. There's another question for you, Dr. Whitney. Can we try the AI ID for my students and when?
Yeah, so I'm going to toss that one back to DePaul. I think that is part of the offering here.
Yeah. So anybody who subscribes to the Discover AI curriculum naturally gets access to the AI IDE, and AI IDE will be available from end of May for schools to try out if you want to do a quick pilot. Um, yeah, so it's a part of the subscription. See, the entire curriculum is also built around this IDE hand in hand, so that they have a tool that students can play around and learn these concepts practically.
Thank you. Mr. DePaul, what about the text-based AI IDs for higher grades?
Of course, the other part of the IDE is built into Python, where they build some of those models using Python-based programming. So our existing Python IDE supports that, and the AI IDE will also have a more advanced mode where students can program. They can convert these blocks into code as well. There will be a switch mode available for higher grades where they can modify the program and in fact create their own custom blocks as well.
Thank you. This is another question for you, Mr. DePaul. What is the minimum bandwidth? Also, what is the recommended bandwidth, considering a class size could be 26?
The bandwidth requirements are quite minimal here. And in fact, once you load the AI IDE or Qubits platform in general, all the IDEs work on the local browser. It doesn't go back to the server and come back. So you only need the bandwidth realistically when you go into Qubits platform, go to the AI IDE and IDE loads. And IDE is intentionally built using very, very light models. So anything as good as, like maybe a couple of Mbps should be megabytes per second, bits per second. That is more than sufficient for this to work. And once that loads, the beauty of it is all happening locally in the browser. If you have any computer that can run any of the modern browsers like Chrome or Safari or Firefox, you are good to go, and you just need that connectivity once the IDE loads. Post that, it's going to run locally on the computer. So very minimal bandwidth requirements. Pretty much any connection will do.
Fantastic. The last question I have for you, Mr. DePaul, is there flexible and tested yearly distribution for the whole curriculum?
Sorry, can you say that again, Sam?
Is there flexible and tested yearly distribution for the curriculum, for the whole curriculum?
Absolutely. So the whole Discover AI curriculum is built into approximately 30 lessons, about 35 hours of instruction, and there are possible extensions available as well. And that's built into that 6 foundations that Whitney spoke about earlier. The introduction to the whole idea of AI, talking about data, the role of data in training and building AI, the algorithms that guide the AI, what those models are, and then of course building AI application, practical AI application using AI IDE and otherwise. And then of course the prompt engineering, the use of AI, using AI for design and different aspects. And finally, the responsible AI element, how to audit the AI output, how to use it responsibly, what to use it for, what not to use it for, all of that. So there is a proportionate distribution of that time also across these topics. And every lesson has more challenges and projects for students if you want to further expand this curriculum as well.
Okay, another question for you, Mr. DePaul. How do you teach something like neural networks in a way that's accessible to younger students?
Yeah, I mean, I think that's quite interesting, So in fact, most of the AI you see today are deep learning, and which is, the this is primarily, deep neural networks. That's what deep learning means, and it sort of mimics our, human brain neurons, although it is not an exact match. Our neurons are far more complex, but the idea is evolved from that. And in fact, this is one of those key ideas that we can teach our students fairly well without, needing a lot of complexity. So concepts such as this, we start with the idea, probably a simulation of a single neuron. We have an hour of AI activity that is available for free for everyone on this as well, wherein we start with the idea of a single neuron, for something like a beach going decision. Should I go to beach today or not? And then starts with the criteria, whether it's a sunny day, whether you have a friend accompanying you, and allocating weights for that. And we teach them how, by modifying the weights, you can change the behavior of this neuron. And starting from there, further extending it to, when what this is, of course, the simplest possible neuron. Real deep learning models have millions of neurons working together, and we expand on this idea further across. But our approach is understand the core idea using a fairly simple simulation, which is functioning, like the squares and the circles experiment that we did. And from there, expand it across to, more larger scale AI applications where there are a lot of neurons are used, but making it all visual, practical by using real projects and, real AI simulations.
One more question, Mr. DePaul. How do you structure the curriculum to move learners from foundational knowledge to advanced application?
Yeah. So again, one of our, sort of founding principle of this curriculum itself is to spiral across different grade levels and, continuously progress. So in the lower grades, K to 2, you will see a lot of, introduction to AI, playing around with AI tools, and understanding what is the intelligence in it, is what not, and trying to appreciate what AI is and the impact of it. And we slowly move to that, the idea of data, and how from data AI can pick up patterns in the, late primary grades. And from the middle schools onwards, they would be start build AI applications, largely using visual blocks, but then practical applications. And when you get into high school, that's where it goes more deep into specific nuances of how natural language processing, generative AI, and computer vision and so on works. And they can also create those models and apply that into, other applications, such as building a website or an app with those models. So the high schools is sort of, bring students to a level where they have, have learned about the data, the role of data, training the model, picking up the right model for the right purpose, evaluating those models output, and applying those models into, practical applications. So yeah, from the very simple basics, and by high school, by end of high school, they are in a level where they can build real AI applications.
Thank you. This is the last question. How do you think this could be implemented in classes for senior students from grade 9 to 12? And would students be able to explore different topics, or should the program follow a structured approach starting from basic concepts, level 1 in grade 9, then progressing to level 2 in grades 10 and 11, and level 3 in grades 11 and 12, and so on? What would your plan be for introducing AI into the curriculum?
Yeah, in our Discover AI pathway, of course, one thing we have kept it in mind is, maybe a grade 12 students might be learning AI for the first time. So our each grade level course, whether that is grade 1 or 5 or 9 or 12, they are all a sort of fresh starts. And of course, based on their grade level and their understanding of other math concept, which very closely relates to computer science and AI, based on that, we might, picking up those concepts in a much faster pace. So students can start from any grade level. We have very carefully curated and organized the sequence of concepts that they have to follow in each grade level. And we strongly recommend, at least for the first year, you follow that as is. And each grade level, we give the introduction concepts of of intelligence, the concepts of data, algorithms, and all of that machine learning concepts for each grade level. So each grade level, students can start independently. Grade 12 students do not need to start from grade 9 level and, then further progress. That we have taken into account while designing the curriculum for each grade level. So you can just pick up the Discover AI course for that particular grade and start readily.
Excellent. Okay, well, I would just like to say a very big thank you to Mr. DePaul and Dr. Whitney for your time and for the session this afternoon. It was absolutely exciting and interesting, fantastic. And for you teachers, thank you very much for being part of the conversation today. We hope that you enjoyed this session. I would just like to say a couple of things. We will be having more webinars coming up in the future. We will keep you posted when they will be happening, okay? Today's session has been recorded, and we will be sharing with you the recording alongside we'll be emailing you with the certificates of participation, okay? And please reach out to us in the chat box. There is our contact details. So please do contact us if you do need anything else, okay? And again, big thank you to everybody for coming this afternoon. Thank you so much for your time. Have a lovely evening. Thank you.
Thank you.
Thank you.